Let's have a quick refresher on equations and inequations. Basic idea. Whatever you're trying to find, make it the subject of the formula. That's the basic idea behind questions, right? Because you want to know what is x. So you want to end up with x equals. It's the subject of the formula. Very simple equation, of course. When you first did these, probably back in primary school or maybe even infants, you did these by guessing. Now, they were very intelligent guessing, of course. And we probably didn't put an x there. You might have had a box or a triangle and say, oh, what goes in the triangle? But that was a very basic form of an equation, probably the first time you saw these things. The idea here, what I do is I think of moving terms. Whenever I move a term, I change its sign. So that positive 3, I'm going to move to the other side, so it becomes 6 minus 3. Yes, in reality, I don't write 6 minus 3 down. Of course, I just write the answer down. But that's how I think about equations, is I move terms to other sides, and then I change the sign. And when it comes to multiplication, remember the key idea basically is you do the opposite operation. And the opposite to multiplication is, of course, division. But we don't write down divided by, because in maths we've got a much neater way of doing that. And that's the whole point of the fraction. So we actually write it as a fraction, and then the answer comes out straight away. And if the fraction can be simplified, obviously we do so. And obviously this one does. 45 on 5 is in fact 9. But if those numbers aren't neat, it's not a problem, because we've got the fraction straight away. We've got the answer. These ones are interesting. You've got a choice, of course. You could expand out first, then play around with it. Or you could divide by the 4 first. Wonder which way I went. I expanded out first. So I've got 4a minus 20. I'm then going to move the 20 to the other side. So I'm going to add 20. Okay, I'm going to divide by 4. Bingo, there's our answer. And then we progressed and we had pronumerals on both sides. Oh my gosh. It's all right. You're allowed to move more than one term. So the 2 I'm going to move over to the right-hand side. The z I'm going to move to the left-hand side. And we end up with 2 z's, negative 11. And here's one of those ones where all I've got to do is write it as a fraction. I've got the answer. 2 doesn't go into 11. Some people are obsessed with mixed numerals. And they don't like leaving it as 11 on 2. They look at that and go, no, can't cope. 5.5. Got to write 5.5. There's nothing wrong with an improper fraction. I suppose it comes down to the context of the answer. If you were doing a practical problem and this was finding a measurement or something like that, and someone would say, oh, how long is the room or something, you wouldn't say, oh, the room's about 11 on 2 metres. In that case, a mixed numeral would make sense. But when it's just an equation, there's absolutely nothing wrong with leaving it as 11 on 2. Okay, fractions. Before we can add, the denominator's got to be the same. But an easier way is just get rid of those fractions altogether. You want to get rid of a fraction? Multiply by the common denominator. In this case, 7y. And then it's very easy to solve. 21y is 19. 19 on 21. Oh, this is a special case. Remember these sort of equations where we have a fraction equaling a fraction? And you can, what we call, cross multiply. Just multiply along the crosses. And so the question becomes 3x plus 9 equals 10x minus 30. So if you've got fraction equals fraction, let's get rid of those fractions, multiply along the crosses, and we'll give ourselves a much easier equation to solve. Move some terms. 7x is 39. 39 on 7. Okay. What's the difference between an equation and an inequation is simply the inequality sign that's in there. Now we've got a couple extra rules, because sometimes that inequality sign will change. Remember, if we multiply or divide both sides by a negative number, then you have to change the inequality sign. The way I remember it is if you change the sign, you change the sign. Okay? So if you change the sign of the number, you change the sign of the inequality. So if you change the sign, you change the sign. There it is. The other situation, it's a lot rarer, but if you were to take the reciprocal of both sides, then you'd have to change the inequality sign as well. Doesn't happen a lot, but keep that in mind. If you turn both sides upside down, that inequality sign should change. Ah, wow, very basic one, isn't it? 6x divided by 36. So we treat it just like an equation. Divide by 6, x is less than 6. Wow, that was tricky. But I want to also point out how we plot these things on a number line, because there are good ways of doing it and there are bad ways of doing it. So 6, in this case, it's not included, and that's why we just circle it. We don't colour it in, because that dot, if you like, is representing the boundary, and we're saying the boundary is not included. And then we have to let them know which numbers are included. I personally prefer just drawing a line above the number line, so there's no confusion. Some people put it on the number line itself, but you can sometimes lose the line on the line. So if you're going to do that, maybe use a different colour or something like that. So I just put it a little bit above. Okay. Here's another difference with an inequation. With an equation, you normally just have a left-hand side and a right-hand side. But you can have 3 sides to an inequation. So whereas it was what we do to one side, we do to the other, with this one, it's what we do to one thing, we do to all things. So the first thing I'm going to do is move the 6, but I'm moving it to everywhere. So in other words, I'm going to take 6 away from everything. So it becomes -4 and so on. So now I'm going to divide everything by -4. But of course, if you change the sign, you change the sign. Now, I don't know about you, I'm looking at this and feeling very uncomfortable. Can't cope. Ooh, that's better. Because that looks nicer. Now, when I say it looks nicer, because if you think of a number line, how often on a number line do you see the number -2 on the right-hand side of 1? Doesn't happen. So I don't like writing my solution that way either. I will write -2 on the left-hand side of 1. Right? So that would be the nice way of writing the answer. Let's plot it for something like that. There we go. This time the boundary is included and I want all the numbers in between. So just a line between the two. So all right, here comes Mr. Simmons' fussy, correct way of writing inequalities. Okay. There's the number line. How do I write that solution? I write it, x is greater than 5. Again, have a look at the answer, have a look at the picture. They look the same. See, the arrow is pointing in the same direction as the sign. No, don't write 5 as less than x. It's not answering the question. Because the question is saying, what is x? So I'm saying, could you please tell me all the values for x? And you give me the answer, 5 is less than x. Oh, that's nice, but what's x? All you've just told me is 5 is less than x. So what? That's not what I'm asking you. I'm asking you what x is. So a better way of answering that is to say x is greater than 5. So you can pick any number you like greater than 5 and that'll be x. Yes, it's fussy, but that's the way, so no. When they're in between, again, I write it like the number line looks. 4 is on the left-hand side, 6 is on the right-hand side, x is in the middle, and we use less than or equal to signs. We don't write it that way because it looks horrible. 6 on the left-hand side of 4, that's just ridiculous. That's just in some sort of alternative universe or something like that will happen. We definitely do something like that. Right? Have seen that before. X is greater than 4 or x is less than or equal to 6. If you think about that very carefully, that is actually wrong. So it's not just a bad way of doing it. It is wrong because the use of the word or. See, 10 satisfies that. X is greater than 4 or it's less than or equal to 6. Oh, well, it's greater than 4. 10 satisfies it. But 10 is not an answer for this inequality. If you did want to write it as 2 and you don't, the correct word to write in there is not the word or, but the word and. But no, wrong, bad. All right, what about ones like this where we go either side of the 2 points? Again, I would write my solution. Look, it looks like the picture again. I've got 2 x's and one's branching to the left, one's branching to the right. So the answer looks like the picture. X is less than or equal to 4. In this case, or is the correct usage. Because we're saying numbers that are less than or equal to 4 or greater than or equal to 6. And if you think about it, and would actually be impossible. You can't have a number that's less than or equal to 4 and greater than or equal to 6. So this would be a correct use of the word or. No. Yes, it's correct, but it just looks horrible. Look, it's pointing inwards, the number, no. Some people try all sorts of weird things like this. I want x in the middle for some reason. 4 is greater than or equal to x is greater than or equal to... That's just wrong. Bad. So, what if?